Okay, in this video, we're going to look at how to factor the GCF from a polynomial. But first I promised I'd put the answers to the distributive warm-up and review problems. So hit pause and go ahead and check these if you didn't check them already. When we factor a GCF from a polynomial, the first thing to do is find the GCF. So my two terms here are 3t squared and negative 18. Since they both don't have a variable, I know there's not going to be a variable in my GCF. So 3 and negative 18. Their GCF is 3. That's the first step. So I'm going to write 3 and then an empty set of parentheses. What we do now is we factor the GCF out. Or in other words, we could also say divide. What this means is take your polynomial and divide each term by the GCF. So 3t squared divided by 3 and negative 18 divided by 3. Now when I do this division, 3t squared divided by 3, these 3's here reduce down to 1, so I'm left with just t squared. And then I have minus 18 divided by 3 is 6. That's how you would factor a GCF. So now we want to check two things. So our third step we could say is check twice. The first thing we want to check is to make sure that this polynomial here inside the parentheses does not have any GCFs. So t squared and negative 6, those don't have anything in common besides 1, so we're good there. The other thing we want to check is check our answer. To check our answer, we're going to use the distributive property. So draw on my arrows. Remember, that's to remind me to multiply. 3 times t squared is 3t squared, and 3 times negative 6 is negative 18. Does that match my original equation? Yes, it does. So that's my second check. That means we can take confidence in that we factored correctly. Here's another example. Again, the first thing we want to do is find the GCF. Look at your coefficients, 5 and 10. The GCF of 5 and 10 would be 5, and then v to the 5th and v cubed. Those would both have 3 v's. So the GCF for this polynomial would be 5v cubed. Write him next to the set of empty parentheses. And now we're going to factor. Remember, that's similar to dividing, because we're going to divide each term by the GCF. So when we divide this first term, 5 divided by 5, that reduces to 1. V to the 5th divided by v cubed, exponent properties say we subtract. So 5 minus 3 would be v squared. Plus, and then my coefficients again, 10 divided by 5 is 2. And then v cubed divided by v cubed, so I would not need a variable there. And then my third is check twice. Check 1, do the terms inside of my parentheses have a GCF? V squared and 2 do not have a GCF, so we're good. Our second check is the distributive property. So draw on your arrows to remind you to distribute to both terms and to multiply. So 5v cubed times v squared would be 5v. Exponent properties say to add the exponents. 3 plus 2 would be 5. And then 5v cubed times 2, multiply the coefficients. 5 times 2 is 10. And then v cubed. Does that match my original? Yes, it does. So we can take confidence again that we factored it correctly. Here's another example. Why don't you guys try this one on your own? Remember, 1, find the GCF. 2, factor. This is the division, so we'll divide. And then finally, don't forget to check twice. Go ahead, hit pause, try it on your own. Okay, so you've tried it. The GCF in this polynomial is 2b. And then I'm going to divide each term by 2b. 4b cubed divided by 2b gives me 2b squared. 2b squared divided by 2b gives me b. And 6b divided by 2b gives me 3. Now I'm going to check twice. The terms that make up the polynomial here in the parentheses don't have any GCFs aside from 1, so that's our first check. Our second check is the distributive property, multiply out. This one has 3. 2b times 2b squared is 4b cubed. 2b times b is 2b squared. And 2b times 3 is 6b. That matches my original, so I can put my check mark there. Let's look at this final example. The first thing we want to do is find our GCF. Now, when I do this one, I'm not going to use the whole GCF because I want to show you a little bit of a process that you can use to make sure that you are getting everything. And so, what if my GCF is 2m? And I'm still going to have my parentheses. Right? And then my second one would be factor. So I'm going to divide out 2m from each term. And when I do that, 6m cubed divided by 2m would leave me with 3m squared. Negative 12m squared divided by 2m is negative 6m. And 24m divided by 2m is 12. And then my third step is check twice. I did this problem this way because notice here, inside my parentheses, this polynomial, the terms have a common factor of 3. So we can repeat our process again. So if I look just at this polynomial, my greatest common factor is 3. And then I'm going to factor that out. Divide each term by 3. So 3 divided by 3 reduces to 1 and leaves me with just m squared. Negative 6m divided by 3 gives me negative 2m. And 12 divided by 3 leaves me with 4. So that's that polynomial factored out. But I still have this 2m here. Bring him down, 2m, and you're going to multiply him. 2m times 3 is 6m. I'll just rewrite it out so my work looks neat. So now check again. The polynomial inside my parentheses, there is not a greatest common factor. That's the first check. The second check is use the distributive property. 3 terms on the inside, so 3 arrows. 6m times m squared leaves me with 6m cubed. 6m times negative 2m is negative 12m squared. And 6m times 4 is 24m. Does that match my original? Yes, it does. So again, we can have confidence that we factored correctly. Now in this example, I realize you probably would have seen that the greatest common factor in my original polynomial here was 6m. But I wanted to do this to show you how you could work through it if you did miss part of your greatest common factor. Okay, so let's go to our reminders. Remember 1, find the GCF. Then we're going to divide or factor the GCF. And don't forget to check twice. So now it's time for you to practice on your own.